Welcome back to another episode of the A to Z of Python. Today's letter E, and that's going to stand for exception handling. And this is a really cool segment. It's probably the favorite one I've done so far, and it's for a very good reason. If you're new to Python, you've maybe written a couple of basic programs, or maybe you're not new, but this is something that you just don't work on, and it's kind of a really bad practice to not learn about exception handling because you're building these little scripts or these programs, and you're not accounting for what happens when you get an unexpected input or when something goes wrong. Okay, so if you're designing maybe tic-tac-toe game or battleship game or a calculator or whatever it may be, what do you do when the user inputs values that you're not expecting, or when you're trying to perform a function in your application and the results aren't what you thought they would be? What do? Does the program just stop running and give some kind of exception, or does it recover and keep going? Well, most of the time, honestly, the thing just breaks, right? So that's not good. It's not the behavior that we're looking for. And ultimately, if you're going to ever do programming in any sort of production environment, especially if the script needs to run for a long period of time, if it can't recover from problems, well, you're not going to be working there for very long. So that's what today's lesson is all about: finding the ways that our programs can be broken and programming our way out of that. And even if it's just the most basic of applications, a few lines of code can take your code from okay to really, really good. And it's a different way of thinking, because typically if you're going to make an application, let's say you're making a calculator and you say, hey, enter a number. Well, if you're running the program and you're testing it yourself, you're going to enter in exactly what the program is expecting. But if a client or some random person gets their hands on your code and runs it, they may not put in exactly what you're asking for. They may put in the number 6 spelled out. And if you're expecting an integer input and they type it in as a string, well, what happens? The thing just blows up, and that's no good. So we're going to talk about a different mindset, and that is building code in a way that you try and break it in every way that you could conceive of, and then you build in some resiliency so that it can recover from that. So we're going to use a very basic coding example, and then we're going to make it very robust. So we're going to do probably the most simple thing I could think of, which is take a fraction input and turn it into a decimal. And the way that's going to work is we're going to take the numerator and the denominator, and we'll take the inputs and we'll return a decimal. Okay, so that's going to say, hey, enter in your numerator value, enter in your denominator value, and then we'll print it out in a decimal form. Now, I'm not going to write a function that takes the numerator denominator values and then returns the decimal. I'm just going to do a basic input and then print the result. Okay, so this will be super basic. So the way we'll do that is we'll just take a numerator and we'll make that equal to input. And this is Python 3. Python 2, it would be raw input, but in Python 3, it's just input. And we'll ask the user to enter in numerator value, and then we'll do denominator. Please enter, okay, so same thing, denominator value, and we'll print out the numerator over the denominator, and there you have it. So 3 lines of code full of problems. Okay, it looks super straightforward. It looks like it would work, but it can't. This code in and of itself can't even run. If we try this, I'll show you what I mean. So we'll run the code. It says enter the numerator value, put in 5, and we'll put in 4 for the denominator, and boom, there you go. So it blows up right off the bat. And if you've used inputs at all to do any sort of math, calculations or anything, you've probably experienced this. And what happens is these inputs are treated as strings. And so we put in 5, the Python stores it as 5, okay, as instead of 5. And this with the quotes on here is a string. It might as well be this or anything. It doesn't matter. It's treating it as text. This is treating it as an actual number, as an integer, and that's what we want. Okay, you cannot do division on this version of an input. You can only do it on numbers. So fortunately, there's a very simple way to handle this error. We just encapsulate our input function into the integer function, and that will solve our problem. So this isn't really exception handling per se, but it is a good step to get our program where we want. So it's a necessary step. So this is a problem and we're resolving it. And these are the steps that you probably take because you can't even run your program without doing these. So these are sort of rudimentary like exception handling, but it's not building a lot of robustness. It's just getting it to the baseline where it will actually run. So if we run this and we give it some valid inputs, like say 7/4, we get exactly what we expect, 1.75. Okay, so the program works now. So that's great. So if the like say your professor or whatever asks you, okay, so today's task is to design an app that will take a fraction and convert it over to a decimal. Technically this works, okay, but it can be broken, and if the teacher wants to make things difficult on you, they're going to ask you to put in a different series of numbers for numerator and denominator, and some of them are going to cause your program to break. So the goal here is to figure out what this could be before they happen and then handle them. So the most obvious one I could think of is using a 0 as the denominator, and that will actually cause a divide by 0 error, which you know in math you can't do that, and Python will give you the nasty error message there. And let's give it a shot and see what that looks like. So we'll just put in any number for the numerator and put in a 0 for the denominator, and there you go. So we have an exception, 0 division error, division by 0. Okay, so you need to make sure that your program at the very basic level can handle when the user puts in a 0 for the denominator, because that will be very likely to happen at some point. And this is kind of just poor programming. If it breaks because someone puts a 0 in, well, you got to do better than that. So how do we do that? Well, we can use something called try and except. And the way this works, it's just a little couple letters of code here, and this is called the try. We can indent this over, and in Python it's going to, when it sees the try, it's going to execute this code, attempt to execute every line of code here, and if it runs through without an exception, then it's no different than not having it at all. Okay, it just goes right through. But if there's an exception, we can tell Python what to do. And that takes the form of the except, and we can say print, like there was a problem. Okay, so whatever. So this is a very broad exception clause, and in fact PyCharm tells us it's too broad. And what this is saying is, if for any reason at all this fails to go through, it's going to print, it's going to stop and print there was a problem. Okay, but we don't want to do that. We want to be more specific. We want to tell the user where they messed up. Okay, so we know that there is a 0 division error, and that's the error that we want to handle. Okay, so let's do except 0 division error, and now we're getting somewhere. So we're actually telling Python how to behave explicitly when we see this exact problem. So every time someone puts a 0 in for the denominator, we're going to handle that, and we're going to recover from that. And so what I would say is maybe we put in like something like print, like so print denominator cannot be 0. And let's try that. So put in a number for the numerator, put a 0, and there you have it. So it says denominator cannot be 0. So we're now handling the exception. We're aware that this could be a potential problem, and we're putting in code to work around it. So it's not ideal yet because there are other things that could go wrong. But what we want to do is we want to also recover from this problem, okay? So I would like it if when there's this exception, we don't just tell them that it's a problem, we restart the application so that they can try again to put in a valid input. And so let's change this from cannot be 0 and just leaving it at that. Let's just say restarting, and let's make this restart. So there's a way to do that, and the way we can create sort of an infinite loop of this is to just type in while true and then indent everything underneath it. And what will happen is this while true is in Python, this means like always run this. Okay, so this statement will always be true, and so it will always run. And so even if, like, as long as it doesn't have an exception, once it gets to the end, it'll start over. And so when you see this in action, if we click run and we do 5.0, okay, it gets all the way to the end, it handles the exception, and then it restarts the app because it gets to the end and true is still true, so it comes back to the top and it goes through again. So we have an opportunity to get another one. Okay, so this is correct, this works, and it starts over again. So what if we want it to exit upon successful calculation? Well, I can go here and type in break, and break will break out of this whole thing. Okay, so this means if we get all the way through without an exception, stop everything and you're done. Okay, so if there is an exception prior to the break, it will skip this break and it will go to the exception handling and it'll do something different. So you'll notice that if I run this and I put a 0 for the denominator, okay, the exception is raised here, so it skips the remaining code and comes down to the exception handling, and which tells it what the specific problem is, and it starts the app again. So if I put in something that works, okay, there you go, prints it out and breaks out. So this is great. So this program will run over and over again if the user puts in a 0 in the denominator. Otherwise, if it successfully runs all the way through, it'll break out and finish. And that's the goal of what we're trying to do here. So let's think, what else could someone do to break this application? Well, what if they put in a non-integer value for either input? Okay, so let's say they put in, they spell the letter out, spell the number out. So we'll put in the number 6, but we'll type it out. Okay, that could theoretically happen. All right, so we get another problem here. Okay, value error. And that's basically telling us that you can't convert the word 6 into an integer value of 6. It just doesn't work that way. So we need to have another exception. So we'll put except, and we know it's a value error, so we'll handle the value error. And we'll put something in like print entries must be integers. And I'll put restarting, okay, because we're still recovering from this and we still want it to bounce back and go again. So now if I put in 6, okay, great. So we've actually recovered from that. What if I put in like a non-integer character? What if I put in nothing? Okay, so we've, at this point, this one's really powerful. The value error catches all kinds of inputs that could cause it to break. Okay, and this one might even be the first one that you figure out, okay, depending on, which way you approach this. But now we've successfully handled pretty much any type of input that's not an integer, and that's probably the primary one. And then we've also handled a valid integer input that causes a division error. Okay, so these two will encompass most of the issues that we'll see here. And already this is like exceptionally better than where we started out. And it recovers and restarts, which is super awesome. So we've got that. Let's see what else we can do. What if we were to get some sort of error here, and it's like an unexpected one? We might not be able to handle that properly as our code is written. It may not even be caught. And so there's a way that you want to design it to where in my opinion, the final function that you're doing here, which in this case is print, is outside of the try clause. It's completely separated. Okay, so we're going to try it this way. We're going to bring this out, and we can do what's called else. Actually, let's do it this way. Let's leave that the way that it was. But we're going to actually assign this to a value. So we're going to put decimal equals. So we're still going to catch the division by 0 error here, because this will generate the exception of divide by 0. Okay? And then to print out the decimal, we're going to do what's called else, and we're going to put in print, and we'll make it look a little bit better. So we'll put like the decimal value of your fraction is, and then we'll put decimal. Okay, so we're doing the input and doing the math in the try section. We're handling the possible errors, and then we're printing out if this goes all the way through with no exceptions. So we're like testing every scenario. Then and only then do we print this out. So this else is executed if the try goes through without exceptions. If any of these exceptions are raised, this will be skipped and the program will restart. Okay, so one other thing that's going to cause a problem is we got to remove this break, because we don't want it to break before it prints. We actually want it to break after it prints. So this is starting to look pretty good. So this will do the inputs, do the math, handle any errors, and if none are raised, it's going to print it out and then the results and then break out of our program. So let's see what happens. So let's try to put a divide by 0. Okay, we recovered from that. Let's put in a non-valid entry. We've recovered from that. Let's put in something that actually works. And there you go. So you can see that it printed and then it broke out. So this is a good programming practice, because this is the part where you attempt to do the logic of your program, and this is where you do something with it. Okay, and these would need to be separated, and this is like sort of the proper style. So there is one other thing that you can do. Two other things that you could do. So let's say we want to handle multiple exceptions at once. So we can just put a parentheses here, and we'll bring our value error up into this except line here. And so what happens is this will catch both exceptions and allow us to handle that. So we need to be a little more vague here. So we're going to say, please make sure entries are integers and denominator is not 0. Restarting. So we can get rid of this. So we're handling value error here, so we no longer need this exception. So let's get rid of that. So we've just shaved 2 lines of code, and we'll handle the errors just the same. So if we run this and we put in a divide by 0, Okay, it handles that. If we put in a non-valid input, it handles it. So you can stack as many exceptions as you want. So maybe you want to handle a series of exceptions with one particular method, and then you want to handle a different series a different way. You can mix and match these any way that you want. So you just keep breaking your program and see what the error is and put it in wherever you want to handle it. And this is very helpful if you have a variety of exceptions that should be handled the same way. Now, in our case, in my opinion, this isn't good for us, because this is like, okay, they need to be integers and the denominator can't be 0. Well, why make this more complicated than it needs to be? And in this case, this is less specific than the way that we had it. So if we undo this, okay, so technically this is more code, but it's more specific. We can tell them exactly why the program failed. So while we could stack the errors under one exception, in this case it's really makes it worse. Okay, so I prefer to be more specific in this exact scenario. So this is, in my opinion, kind of like the ideal layout for what we're trying to do. Now there's one more thing that you can do that's kind of neat, and it's called finally. And this is a bit of code that will be ran every single time that the try function gets executed, and it will run no matter what. Even if there's an exception, even if you use like the keyboard interrupt, like Control-C to break out, it's going to run every time. And to show you how that looks, maybe we put in like thanks for using our app. Okay. Now this is going to print every single time this loops through, no matter what. So let's give it a shot. So we put in something that breaks it, like a divide by 0, and it runs it even though there's an exception. Maybe we put in like an invalid entry. Okay, so it's handled, it recovers, but then it prints the finally as well. And even if we do it successfully, it still prints it out. So this isn't really viable for our situation, because we don't want it to print out even when there's a failure. But there are some scenarios where you might want to run code that executes even if there's an error, even if it's an exception, even if it's an uncalled exception, or even if it's a properly handled exception. And while it doesn't really help us in our situation, it is worth learning. So if we get rid of that, here you have it. We've started from 3 lines of code, and we've taken it into something. So like we've had these 3 lines of code here, which is where, you know, a beginning programmer would probably start, and we've converted it into this. And this will not fail, it will recover, and it will ultimately guide the user into the proper input and give them the result that they're expecting. People are expecting robust applications. This will blow up at any second if they put in the wrong thing. So that's the basics, that's how it works. You can try these out in your own applications, and I urge you, when you're developing your programs, to think about ways that it could break, and proactively try and break your apps and build in these recovery options into it. So that's the lesson for today. Hope you enjoyed, and thank you very much.